A new fighter jet has stunned military analysts worldwide. China's White Emperor fighter jet is a sixth-generation aircraft that has redefined the future of aerial and space combat. This aircraft combines advanced stealth technology, advanced weapon systems, and dual-environment capabilities that allow it to transition between air and space operations seamlessly. Designed to dominate both the skies and the near reaches of space, the White Emperor is far more than just another stealth fighter. What does this bold advancement mean for the future of warfare? Could this new fighter jet signal the dawn of a new era where air and space combat merge seamlessly? Join us as we explore the insane capabilities of China's White Emperor fighter that has shocked the world. At first glance, the White Emperor looks every bit the part of a futuristic warrior. Guess what? It is, in all senses, a futuristic air fighter. Its sharp, angular design reduces radar visibility, making it virtually undetectable to enemy detection systems. The sleek, multi-sectional canopy minimizes radar reflections and protects a pilot from infrared and laser targeting systems. With its compact delta wings and sharp edges, this fighter is built for aerodynamic efficiency, allowing it to achieve supersonic speeds while maintaining high maneuverability, which is crucial for evading enemies and striking with precision. But what sets the White Emperor apart is its dual-environment capability. This is not just a fighter jet for conventional aerial warfare, but an integrated air and space fighter, designed to operate seamlessly in both atmospheric conditions and near space. The White Emperor represents the future of aerospace operations. While the full details of its propulsion system remain classified, it's clear that this aircraft can combine hypersonic speeds and advanced fuel efficiency, enabling it to operate across vastly different environmental conditions, from high-altitude air combat to the extreme pressures and temperatures of near-space missions. Internally, the White Emperor is built for maximum flexibility and power. Its expanded weapons bay accommodates heavier payloads, including advanced air-to-ground munitions, while maintaining its stealth capabilities. The jet's advanced avionics suite improves cockpit ergonomics, integrating state-of-the-art pilot machine systems that provide real-time data analysis, ensuring pilots can make informed decisions under intense pressure. Beyond combat, the White Emperor could serve as a powerful reconnaissance platform, using its stealth and sophisticated sensors to gather critical intelligence without being detected. Part of the broader Nanchaman project, this fighter embodies a new vision for both air and space combat. The White Emperor positions China to tackle not just aerial threats but space-based ones, such as countering reconnaissance satellites and potentially deploying future weapons into space. This change transforms space from a peaceful domain into an active theater conflict. The White Emperor's implications extend far beyond its technical specifications. It challenges a global balance of power, forcing other nations to reconsider their military strategies. With comparisons already being drawn to the United States Next Generation Air Dominance (NGAD) program, China's rapid progress is forcing a re-evaluation of the future of military aviation. This aircraft also signals a deviation in how people think about space. Space has been a domain of scientific exploration and passive defense for decades. However, with concepts like the Lunglong space carrier and unmanned space fighters like Zhonlu, China is proving that space is the next frontier for military engagement. The White Emperor is just the beginning. This initiative is exciting because China isn't just trying to catch up with other nations. It wants to leap ahead. Major Chinese aerospace organizations, including the Aviation Industry Corporation of China, are investing heavily in technologies that will shape the future of fighter jets. These include artificial intelligence, new propulsion systems, and previously thought impossible advanced materials. Research centers are filing patents for these innovations, testing new designs in wind tunnels, and publishing groundbreaking studies on quantum sensors and AI-based flight controls. China's approach differs from previous efforts because it is not just about keeping up with the rest of the world. The research shows that China aims to develop technologies that are still just ideas in other countries, positioning itself as a leader in military aviation. While there's a lot of excitement around this new fighter jet, it's important to focus on what has been officially confirmed through real sources, including government statements and documented research. This helps separate fact from speculation and gives us a clearer picture of China's goals. According to official documents from China's Ministry of National Defense, the next-generation fighter project isn't just about making a better jet. It's about completely rethinking what a fighter jet can do. The plans for the new jet focus on 5 key areas that go beyond the capabilities of current fifth-generation jets, such as improved stealth and better flight control. One of the most exciting innovations is what Chinese aerospace engineers call multi-domain fusion. This capability would allow a fighter jet to gather and process information from the air, space, land, and sea simultaneously. This is a major advantage in terms of intelligence gathering and decision-making, making the aircraft more aware of its surroundings in real time. Prototypes of these advanced sensor systems have already been demonstrated at the Zhuhai Air Show, showcasing China's progress in integrating these complex systems into its aircraft. Another advancement comes from the development of advanced engines. The Aero Engine Corporation of China is working on designs that promise to significantly enhance the thrust-to-weight ratio by 30%, making fighter jets more powerful and efficient. However, this increase in power isn't just about raw force. The engines are being designed to adjust their performance in real time based on changing flight conditions. This will allow the aircraft to adapt to different combat situations, ensuring optimal performance during every mission phase, whether at supersonic speeds or in extreme environments. Regarding stealth technology, China is going even further than traditional radar-evading designs. Researchers are developing new composite materials that don't just make the aircraft harder to detect. They actively adapt to different types of sensors. Think of it as a chameleon that can change its color to blend in with its environment. Except in this case, the materials would adjust their radar signatures to avoid detection by different enemy systems. This innovation is expected to give China's future fighter jets a significant edge in stealth operations. Another key feature that sets China's next-generation fighter jets apart is their hybrid autonomy. While fully pilotless jets aren't on the horizon, this technology will allow pilots to remain in control while receiving AI-powered assistance. The AI will help with tasks such as identifying targets and determining the most efficient flight paths. This collaboration between human and machine is expected to improve operational efficiency and make the jets more agile and responsive in combat scenarios. Developing directed energy weapons is another area in which China is making strides. While the technology for lightweight laser weapons is still in its early stages, Chinese researchers have demonstrated significant progress in the underlying technology needed to build them. Directed energy systems have the potential to revolutionize warfare, offering the ability to disable or destroy enemy targets with precision and speed, all while reducing the need for traditional munitions. These technological breakthroughs are not just hypothetical, they're being demonstrated in real-world prototypes. At recent Chinese technology exhibitions, companies have shown working models of advanced radar systems, new composite materials, and AI-driven flight control systems. These are not merely concepts, but tangible technologies that are being refined for future use in military operations. China's timeline for achieving these advancements is ambitious yet grounded in reality. The government has publicly stated its goal of reaching key development milestones by 2027, with even further advancements planned through 2035. This methodical approach, with clear technical benchmarks at every stage, demonstrates that China is committed to making these futuristic technologies a reality. Universities, research institutes, and manufacturing facilities are all working together to meet these ambitious goals. This collaboration is evident in the many patent filings, research papers, and public demonstrations released to showcase China's progress. One of the most impressive areas in these developments is China's focus on engine breakthroughs, which are quickly gaining attention in the aviation world. At the heart of this innovation is the WS-15 engine, recently showcased at aviation exhibitions. This engine represents a major milestone for China. While it does offer impressive raw power, its true value lies in its construction. The engine's turbine blades are made from single crystal materials, a technique that only a few countries have mastered. These blades can withstand extreme temperatures far hotter than lava while spinning at speeds greater than those of a hurricane. This makes the WS-15 engine one of the most powerful and durable engines in the world, capable of delivering thrust levels above 30,000 pounds, placing it in league with the best engines globally. But the WS-15 engine is just the beginning. Chinese aerospace companies are also pioneering adaptive cycle engines, a concept that stands out for its ability to adjust performance during flight. This means the engine can switch between modes depending on the needs of the mission. For example, it can operate like a sports car, delivering maximum performance when needed, or switch to an economy mode, saving fuel when less power is required. This ability to change on the fly greatly enhances fuel efficiency, with official test data showing a 15% reduction in fuel consumption compared to previous models, all while delivering more power. This translates into longer flight ranges and improved overall performance for fighter jets. Materials science plays a critical role in these breakthroughs, as advanced materials are being used to increase efficiency and durability. Published research papers show the progress made in crafting stronger, more heat-resistant materials for these engines, which is essential for their high-performance capabilities. These innovations in engine design and materials are set to give China's fighter jets a significant edge, enabling them to perform better, longer, and more efficiently than ever. In addition to their adaptability, power, and fuel efficiency, these engines position China to challenge the traditional boundaries of air combat. By combining advanced materials with intelligent design, China is pushing the limits of what's possible in aviation technology, ensuring that its future fighter jets will be faster, more powerful, and more efficient. This focus on practical, achievable breakthroughs sets the stage for a new era in aerospace defense. One of the most significant advancements is ceramic matrix composites. Chinese engineers have developed these high-performance materials that can handle extreme temperatures far beyond the limits of traditional metals used in jet engines. What's impressive is that these composites are already being used in engine testing. These developments are even more remarkable because China is doing it all independently. Footage aired on state television has revealed highly advanced manufacturing facilities filled with precision robotics and automated systems that rival those in Western countries. But the advances don't stop with materials. China has made eye-catching progress in integrating artificial intelligence into advanced aircraft systems. At the China International Aviation Exhibition, Chinese aerospace companies proudly display prototypes of aircraft fitted with AI-driven flight control systems. The Aviation Industry Corporation of China showcased its cognitive systems, designed to give aircraft the ability to process data from multiple onboard sensors in real time. Essentially, they give the plane a brain to interpret its surroundings and make decisions like a human pilot would. In recent public demonstrations, these AI systems have been shown to handle complex flight maneuvers and make instant tactical decisions regarding flight paths, threats, and evasive actions. These are not just speculative technologies still trapped in the simulation phase. China has already tested them in flight simulators and limited real-world trials, proving they can function outside controlled environments. One of the most promising breakthroughs comes from the Chinese Academy of Sciences, where engineers have developed AI systems designed to work with human pilots. Instead of replacing the pilot entirely, these systems handle routine tasks like navigation, monitoring systems, and managing sensors, while leaving critical high-stakes decisions in the hands of the. It's like having an ultra-reliable co-pilot that never tires, never gets distracted, and can process massive amounts of information faster than any human. The sensor fusion capabilities developed by Chinese engineers are particularly impressive. Using advanced AI, these systems can merge data from radar, infrared, and electronic warfare sensors into one cohesive view of the battle space, faster and more efficiently than any human crew could manage. These developments stand out even more because they are no longer just being tested in labs or simulators. China has integrated these AI systems into aircraft hardware, proving that they function effectively in real-world flight systems, not just computer models. Recent footage from Chinese state media has showcased test pilots working alongside these AI systems in highly advanced simulators. Verified results from these tests demonstrate that AI-driven systems provide faster reaction times, superior situational awareness, and improved mission performance compared to traditional systems. Despite the advanced automation, safety remains a top concern. Published documents confirm that China has built multiple layers of redundancy and fail-safes into these AI architectures, ensuring that full control is instantly handed back to the human pilot if anything malfunctions. This safety protocol has been repeatedly demonstrated in public flight tests, proving the reliability of the systems in both simulated and real environments. China's impressive push forward is supported by a rapidly growing network of research and testing facilities. Through satellite imagery and state media reports, it's evident that China is making significant investments in constructing new state-of-the-art testing centers nationwide. One of the most remarkable facilities is Beijing's newly built hypersonic wind tunnel. This facility can test aircraft designs at speeds up to Mach 8, allowing engineers to evaluate performance under conditions that simulate extreme high-speed flight. In another interesting move, the Chinese Aerodynamics Research and Development Center has constructed the world's largest pulse detonation engine testing facility. This enormous complex spans over 6,000 square meters and is equipped with some of Asia's most advanced aerospace testing tools. Public demonstrations have shown Chinese engineers experimenting with new engine types that could potentially revolutionize how fighter jets operate, focusing on propulsion methods that are more efficient, powerful, and adaptable to high-speed combat. Another unique aspect of China's approach is its decision to develop an independent research ecosystem. Rather than depending on international partnerships, China has built its own network of specialized research hubs. The Aviation Industry Corporation of China has established research centers in every major industrial city, each focused on aerodynamics, propulsion, avionics, or stealth technology. This self-reliant model allows China to accelerate innovation while controlling every step of the process. Published research from these institutions highlights major progress, including breakthroughs in thermal management, an issue that previously limited the performance of high-speed fighter jets. Chinese engineers have now developed advanced cooling systems capable of handling the extreme heat generated during supersonic and hypersonic flights. Quality control in China's aerospace sector has also reached a new level of precision and sophistication. Recent footage from state media reveals automated inspection systems that use artificial intelligence to check aircraft components. These systems can detect defects as minor as a human hair, an essential capability when building advanced fighter jets that must perform flawlessly at high speeds and extreme altitudes. Supporting all this, China has expanded its data processing abilities dramatically. New supercomputing centers dedicated solely to aviation research can simulate entire aircraft systems in stunning detail. This dramatically reduces development time by allowing engineers to test and refine systems virtually before any physical prototypes are built. China has also invested heavily in facilities designed to test stealth technologies. Advanced radar cross-section measurement ranges have been constructed where engineers can precisely measure how visible an aircraft is to different types of radar. Recent public tests have shown that the latest Chinese aircraft designs have achieved significant improvements in stealth performance compared to earlier generations. The scale of China's aerospace manufacturing has also grown massively. Satellite imagery has revealed enormous new production facilities in places like Chengdu and Shenyang. These factories span millions of square feet and are some of the most advanced aerospace manufacturing centers in the world. Inside these facilities, robotics plays a key role in every step of production. State media has shown automated systems handling everything from composite material layups to precision machining tasks, working with accuracy levels finer than a human hair. This is vital for ensuring the tight tolerances needed for advanced fighter aircraft. One of the standout technologies of the Shenyang facility is the world's largest titanium 3D printing system. This enormous machine can produce complex aircraft parts that would be nearly impossible to create using traditional methods. Public demonstrations have shown this machine printing full-scale aircraft components in a matter of days, cutting production time significantly. Sophisticated quality control systems are in place to ensure these parts meet the highest standards. Advanced X-ray inspection systems scan every critical part, and artificial intelligence analyzes the images to catch even the tiniest flaws that human inspectors might miss. China has also mastered the ability to work with advanced composites at scale. Their new automated fiber placement machines can lay down composite materials with perfect precision, layer by layer. This technology is crucial for creating stealthy, strong, and lightweight aircraft that can handle the extreme demands of modern combat operations. A new electronics manufacturing facility has been built in Shanghai to support these efforts. Clean rooms larger than football field produce the sophisticated radar systems, avionics, and electronic warfare equipment that modern fighters require. These capabilities have been showcased at technology exhibitions, proving that China's aerospace industry can now produce world-class electronic systems entirely on its own. These developments, from AI-driven quality control to giant 3D printers and stealth testing ranges, show that China's aerospace sector is no longer just catching up. It is building the infrastructure and capabilities to compete at the highest level globally. Thanks for watching.